Hello there, children. Today we are going to work on some of the recordings that you requested. So, first and foremost here, problem 47 from review 1. Ooh, this nasty looking sine function. The first thing you got to do is you got to create yourself some equations. Now, I want to know where the 0, the pi over 2, the pi, the 3 pi over 2 are going in this function. The reason I want to know that is I want to know where my 5 quote-unquote pretty points are going. Now, when I solve this equation, and then I divide by 4, I get 3 pi over 16. That's where my 0 now resides. I want to know where pi over 2 goes. Now, this one is going to take a little more work because you need to get yourself one of those fancy smancy common denominators. That would get me here 5 pi over 4 equals 4 theta divided by 4. I get 5 pi over 16. Now, at this point, you can keep making equations or realize what we talked about in class. Hey, wait a minute. These are all have to have the same distance. So the distance between this and this will carry throughout all the problems. So now I know my 5 points because the distance between 3 pi over 16 and 5 pi over 16, well, that's just 2 pi over 16 or pi over 8, which if you think about it kind of makes sense because our old distance used to be pi over 2. We divide that by 4, it's pi over 8 or 2 pi over 16. Oh, happy days are here again. What a fine day for mathematics. So now I plot my 5 pretty points. I do that. Now, the rest of the transformations come into play. What the heck is going on here, you might ask? That's a very astute and good question. What I'm going to do is look at the numbers I have. It's the sine function, so I'm going to multiply my y values by 1/2 and then add 1 to them. So when I do that, I used to start at 0. Multiply 0 by 1/2, 0. Add 1. Boom, right there. I used to go up here to 1. Multiply that by 1/2. Add 1 to it. Then back down here. Now, I made a mistake here. What was my mistake? I started at 0. I was hoping somebody would notice that, but then again, I'm talking to myself. So remember that this no longer is my starting point. So I've got to be eerily careful of that. This is my new starting point. So I'm starting here at 1. That's a common mistake. Everyone wants to start at 0 because they're always used to starting at 0, but that's not necessarily what happens here. Now this one, -1 times 1/2, -1/2 plus 1, that's 1/2. And then I graph my cosine function or my sine function. In this case, it's sine. Done deal. Oh, happy days are here again. Same thing here. It's equation time. Because again, I want to know where it goes at 0. Trust me, the singing doesn't get any better. So I do this. Now, I'm going to multiply both sides by 3, which gets me -5 pi over 2 equals theta. Oh, happy days are here again. Then I figure out where the pi over 2 goes. That's what I'm concerned by here, because I want to know where my quote-unquote 5 pretty points go. Alright, so I get -pi over 3 equals this. Multiply both sides by 3. I get -pi. Well, that's great. That's wonderful. Now, I need to find the difference between these two things. Now, no common denominator this time, but remember that this is really -2 pi over 2, which is -pi. So what's the difference between -5 and -2? Well, I'm just adding 3 every time to move all the way over. which is a big key point. Now, what's goofy about this one is I have some on the negative side here, and this is where you run into some people who have a little bit of a problem here. Now, you might ask, why am I doing all of this? Well, I'm adding 3 to the numerator here. That was negative 2. So now it'll be 1. So now it'll be 4 pi over 2, or 2 pi. And yes, folks, you must actually reduce these things. And this is now 7 pi over 2. Now we go on and look at my transformations. All right, I have a 2 out in front here. That means multiply all the y values by 2. That's a minus 1. That means take them and subtract them by 1. So let's look here. This is my starting point. This is where my 0 now goes. I was starting at 0. Multiply 0 by 2. 0. Subtract 1. All right, down at negative 1. Bam. Over here, I used to be at 1. Multiply it by 2. Get 2. Subtract 1. Boom. This isn't a point at 0 now. Be very careful of that. Back down here. Because I was at 0. 0 times 2, minus 1. Down here, I was at negative 1. Multiply that by 2, get negative 2. Subtract 1, I get negative 3, all the way down here. And then boom. And connect your dots. Sound effects optional. There you go. There is my graph of the sine. Moving on. Okay, this function's a little different here. Given cosecant, now what is the definition of cosecant? That's 1 over sine, but more specifically for what we're going to use for this problem, it's opposite over hypotenuse. Now, if you look here, the angle is between 90 and 180. If I draw my coordinate axes, that means my angle is over here. Drop a right triangle down. All right, opposite was, this was sine, right? That's the definition of sine. So, given cosecant is my hypotenuse over the opposite, I have my hypotenuse being 13, my opposite being 5. I need to find this side. Well, if you remember Pythagorean theorem, if you don't, a squared plus b squared equals c squared. I get 5 squared plus b squared equals 13 squared. That's 25 plus b squared equals 169. B squared equals 144. That means b equals plus or minus 12. And remember, since I'm over on this part, my x's are negative, so I get a negative 12 over here. So then I need to figure out, and here's my theta in the corner. I need to figure out the rest of my 6 trig functions. Well, first off, you ought to know what sine is. If they give you cosecant, you automatically know what sine is. You're given the cosecant already. Cosine is adjacent over hypotenuse, negative 12 over 13. Once you know that, you know the secant is negative 13 over 12. Again, you can put the negative wherever you want. Tangent is opposite over adjacent. That's negative 5 over 12. Again, I'm putting the negative up top. Cotangent equals negative 12 over 5. Again, I'm putting the negative up top because it looks cleaner. There you go. I have defined all 6 trig functions as asked. Now again here, 56, cosecant equals 5 over 3. Remember, cosecant definition is hypotenuse over opposite. This part here is a little tricky, saying that the secant is less than 0. Well, that's just 1 over cosine, folks. That means the cosine is going to be negative. And cosine is x. So I'm over in this area again. Now, why am I not down in this third quadrant? That also is cosine negative, because this is positive. If that were negative, then yeah, I'd stick down there. Remember, my hypotenuse can never, ever be negative. So I draw my right triangle. Boop! My theta. I get hypotenuse. I get opposite. We should all know that's -4, 3, 4, 5 right triangle. And then I go ahead and define the rest of my trig functions. I automatically should know what sine is if given cosecant, because they're the reciprocals of one another. I know what cosecant is because, well, they told me that. Thank you, sirs. Cosine adjacent over hypotenuse, with the secant being the flipped version of that. Again, I'm putting the negative up top because it looks nicer. Tangent, opposite over adjacent. That's 3 over -4. And cotangent is -4 over 3. Oh, happy days. Go henceforth and do.